Hey guys, this is Saptarshi here and welcome to our YouTube channel. So today we are going to look at how to build a basic neural network based classifier for binary classification. So we'll use our regular Jupyter notebook and Kaggle environment. So this notebook link will be available in the video description. So you can run the code on your own and experiment. Okay. So let's start by doing our usual imports. And if you notice that there are a couple of new entries which we have not done earlier. So one is a TensorFlow and another is Keras. So I'm going to talk about them in a short while. So we are going to focus on whether to use scikit or sklearn, which we have been used so far. We'll look at how to feed the model. We'll see that how that can be used for prediction, and we'll also look at how to inspect about the configuration of the model. And we will also have a discussion about different choice of loss functions for the classifier. Okay. So sklearns do have options of building classifiers. Okay. So you have a perceptron for building linear classifiers, and you have MLP classifiers for building non-linear complex classifiers. Okay. And they are generic. Okay. So they support different parameters like activation function, different kind of layers, different kind of regularization options. However, at this point of time, you have two choices. One is that you use this kind of libraries, or at the advent of deep learning, there are some libraries which are specialized for deep learning, like TensorFlow and Keras. Okay, so you can use your regular sklearn, and you can use your TensorFlow and Keras combo. Okay. However, my recommendation is that as you can do an amazingly long list of things using TensorFlow and Keras, so this is your future, right? So probably for building a simple neural network classifier, it doesn't call for TensorFlow and Keras. However, it will be a good idea to adapt to this way of programming. Okay, all right. So this is kind of the architecture. So there is something which are called as a backend, which are low-level deep learning libraries, talking very closely with the hardware CPUs and GPUs. Okay, so one such library is TensorFlow. So there can be many. So as Keras sits on top and serves as a front end, so this is like we interact with sklearn, we are going to interact with Keras, not directly with TensorFlow. Okay, and that's why it serves as a front end. And as it supports multiple deep learning libraries, we call it as a multi backend. All right. Okay. Now let's start by importing a simple library, breast cancer, which we can use for classification. Okay. So let's look at some of its top rows. Okay. So if you look at the top rows, it has got a ID column and then some attributes about the breast tissue. And finally, you have the class attribute. So this is the thing that you are trying to predict. All right, and you have all these attributes. So first, what we are going to do is we are going to set up our x and y. So x is your this attribute, this cell thickness to your mitosis. This attributes, right? So which is actually your second to 10th column, right? So 9 input variables, and finally you have one output variable which is in the 11th column. This ID is patient ID, which doesn't have a bearing, so we have not included the 0 over here. Okay, so we need to do some pre-processing. The first pre-processing is we need to convert this class variable benign and malignant to 0 and 1. So for that, we are going to use our pre-processing library. We are using label encoder, and we are going to apply that on y. So y was having value of benign and malignant. Your encoded y will be having value 0 and 1. And then we are again using a scale attribute from pre-processing. So basically that will ensure that all input variables are on the same range. So they don't affect the way a neural network learns, or the way neural networks weight are differently. Okay, so that's why you need to scale. So let us do this pre-processing. And then let's do a trend test split. Okay, so you see that we are not using the original xy, we are using x scale and encoded y. Test size we have taken as 0.2, so 20% as your testing set, and random state you can use any value. So basically, this is for reproducibility, the seed value. Now there is a demarcation. So we are not using sklearn libraries anymore. So we are using a Keras library and we have initialized a sequential model. So why a sequential model? So neural network can be treated as a sequential model. So basically you have a input layer. From the input layer, it goes to the hidden layer, then to another hidden layer, maybe multiple hidden layers, and finally to the output layer. So as there are layers stacked, so this is called as a sequential layer. Okay, and if you have watched our activation function video, then you know that ReLU is one of the most used activation functions. Okay, so we are going to use this. Okay, and we have actually used 3 layers over here. So basically, if you consider the input layer also, it will look like 4 layers, but input is just a pass-through layer. Okay, and here what we are saying is there are 9 input features, all right, and then first hidden layer you have used 20 neurons, okay, and then second hidden layer you have 8 neurons. Both the hidden layers you have used activation function as ReLU, and this is your output layer, the final layer. And as it is a binary classification problem, you only have one output neuron and the activation is sigma. Okay, so you can quickly so let me run this first, and then you can quickly look at a very block diagram level representation of this neural network. Okay, so this is this is kind of a pass through layer, right? So you have input and that's what you are getting as output. In the hidden layer, these 9 inputs are going and then you are getting an output of 20. Then in the next hidden layer, this 20 is going as an input and output is 8. And then finally to the output layer, these 8 are going as input and the output is only 1. Okay, so that's how you can visualize. So 4 layers, as I said, if you consider the input layer. Okay, and if it is a binary classification, if it was a multi-class classification problem, like if you have 10 layers, 10 classes, then last layer will be like model.add, you add 10 neurons and activation function is going to be softmax. Okay, so that's how you build the model. Now you need to compile the model. So this is also some of the thing which is different. Okay, and so if you need to compile, couple of things that you need is the loss function. So binary cross entropy is the loss function. Okay, and then what optimizer is you have used. So far we have talked about gradient descent, stochastic gradient descent and all that. So that is what is our optimizer, and you are also going to report one metric for all the iterations that you have. Okay, so let's compile this model. So once we have compiled this model, now we can actually fit this model. Okay, and we are using 100 epochs. Okay, so this will take a little bit of time because one epoch is like one iteration through the data, and you will see that there is a loss function which is going down and an accuracy which is going up. Okay, so this is how it will go up, and it is done. Okay, so let's quickly look at. So we are again taking help of pandas and matplotlib to look at how from epoch to epoch this loss function and this accuracy has improved. Okay, so you can understand this is the loss function. So loss function has gone almost to 0. Okay, and as epochs have increased, you have gone very close to the training set classification accuracy. Okay, so you are close to this 100% accuracy mark. Okay, all right. So as I was talking about, so you can just use binary cross entropy, what we have used here when there are 2 classes. Okay, you can use categorical cross entropy when more than 2 classes are there and classes are used as one hot encoding, right? So one hot encoding means that if there are 3 classes, right? So you have a vector of 3 elements, okay, and whichever class is on, you keep that bit as on. So this is a binary string. Okay, only one bit will be 1, rest will be 0. Sparse categorical entropy you can use when more than 2 classes, however the class labels are provided as integers. So you have kind of 1, 2, 3, etc. And some other optimizers that you can use are RMS prop, Adam, etc., which we will discuss in more detail. Okay, so in summary, today we have seen that how you can use this TensorFlow and Keras framework to build a very simple binary classifier, model. Okay, and I am not, so I just missed out the testing set accuracy. Okay, this was training set. Okay, and the testing set accuracy is 95.6%. So it is not as high as your testing set accuracy, because the neural network models has a lot of lot of way to actually overfit, because it has a lot of parameters. Okay. uh, all right, so now let's look at the summary. So this is the summary looks like. So this is what we have already visualized. So apart from that, it also tells about the number of parameters. So number of parameters means the number of basically the number of weights and biases that are being used throughout the neural network. So just think about it, right? So in a linear regression problem, the parameters that you had was only beta 0 and beta 1. Here you have used 377 parameters. Okay, so that's why neural networks are quite a different and complex type of beasts to tackle. Okay, coming to the summary, so we have learned how to build or use this TensorFlow and Keras to build a simple binary classification problem. So we have purposefully not discussed over many nuances of TensorFlow and Keras, which is not required right now. So in next session, we'll see how we can use TensorFlow and Keras for a regression problem. Thanks so much guys for watching this video, and if you find it helpful, do your regular drill like giving your comments, like and subscribe. Thank you so much guys. Take care.